Welcome to Study Loop.
For this problem on the topic of waves and sound, we are told that a prankster drops a waterfall balloon out of a window. We are given the height above the target at which the balloon is released, and we're told the balloon is released from rest, and the prankster then shouts a warning after the balloon is released. So if the warning is shouted after the balloon reaches a certain point, it will do no good, even if the target could react infinitely quickly. Now, if we assume that we are given the air temperature to be 20 degrees Celsius and ignore the air resistance of the balloon, we want to determine how far above the man's ears this point is where the warning should be shouted. Now we must determine the time t for the warning to travel the vertical distance h, which is 10 meters, from the prankster to the ears of the man when he's under the window. Now the desired distance above the man's ears is the distance that the balloon would travel in this time, and we can use kinematics to find this. So sound travels at constant speed, and the distance h is related to the speed by h is equal to vs times t, where h is the height above the window, 10 meters, vs is the speed of sound, and t is the time required for the warning to reach the ground. So if we rearrange this equation, this warning time t is h over vs, which is the height of 10 meters above the ground divided by the speed of sound at 20 degrees Celsius of 343 meters per second, which gives us the time for the warning to reach the man's ears to be 0.0292 seconds. We now need to find the distance that the balloon will travel in this time. And we need to find the balloon's final speed after falling from rest for 10 meters. So we can use the equation that Vy squared is equal to the initial speed in the y direction, V0 y squared, plus the acceleration of the balloon, 2a y times the y displacement. Now we know V0 y is 0 since the balloon starts from rest. So this means that Vy is equal to the square root of the above equation, which is the square root of 2ay y. So we said V0 y was 0, and this is equal to the square root of 2 times the acceleration due to gravity, which is 9.8 meters per square second, times the vertical distance which the balloon is falling, which is 10 meters. So we get the final speed of the balloon to be 14 meters per second. Now, using this result, we can find the balloon speed at 0.0292 seconds before it hits the man by solving the other kinematical equation, that Vy is equal to V0 y plus ay times t for the initial speed V0 y. So V0 y, by rearranging, is equal to the final speed Vy minus the acceleration times time. So this is the final speed of the balloon, 14 meters per second, minus the acceleration, which is only due to gravity, 9.8 meters per square second, times the time of 0.0292 seconds, which gives us the initial speed of the balloon V0 y to be 13.7 meters per second. So this is the balloon speed at 0.0292 seconds before it hits the man. Now we can find the desired distance y above the man's head using the following equation. So the distance y is equal to V0 y times t plus a half ay t squared. So the value for v naught y is 13.7 meters per second, and it will travel for a time of 0.0292 seconds plus a half times the acceleration due to gravity, 9.8 meters per square second, times a time of 0.0292 seconds, and that's squared. So we get the vertical distance above the man's head, at which point the warning needs to be shouted, to be 0.404 meters.